All right, so today we're going to talk about graphing rational functions. Okay, and when we're graphing rational functions, what you're going to see is you're going to see these notions of dotted lines on the graph. Okay, so like here we'll have one at x equals 5, and then we have another dotted line at the equation y equals 2. And those dotted lines are called asymptotes. And what asymptotes are lines that the graph approaches but never touches or crosses. Okay, as you can see here, these black lines are going along the dotted line path. Okay, we have three types of asymptotes. We have vertical asymptotes. Okay, and vertical asymptotes correspond to the zeros of the denominator. So they're in the denominator. We'll take that and set it equal to 0. Horizontal asymptotes are y values on the function that we can approach but do not actually reach. So they're y values that we actually approach but do not reach. Okay. Oblique or slanted asymptotes occur when the degree or the exponent of the polynomial in the numerator is bigger than the degree or exponent of the denominator. Okay. So in our previous example, if you look here, they're both a degree of 2. Okay, and since they're both a degree of 2, this does not have a slanted asymptote. So both numerator and denominator have a degree of 2. So below here, this is an example of one with a slanted asymptote. So as you can see, this graph, they approach this line, but they don't actually cross it. That's the y equals x line. We'll explain how you get these lines and all this stuff in a second. Okay. So when you're graphing, you must find two things. You must find all the intercepts, both x and y. Okay, so both x and y, and all asymptotes. You must find all those asymptotes. Okay? Let's do an example. All right, so there are 4 steps to doing this. Step 1, find the y-intercept. Okay? When you find the y-intercept is simply just these two numbers divided. So y is going to be -6 divided by -1. So it gives me a point of y equals 6. But remember, a y-intercept is a point. So our point would be 0, 6, because every y-intercept is when x is 0. Okay, so we need that. That's important. Find the x-intercept. To find the x-intercept, we need to take our numerator of x squared minus x minus 6 and set it equal to 0. Okay, so we're going to take this and now we're going to solve. We can do this x method, negative c over -1, which gives me points at -3 and -2 and +2. So that breaks down to x minus 3 and x plus 2, which gives me x at 3 and an x at -2. So those points would be 3, 0 and -2, 0. So we have those 2 points that we will be graphing here in a second. Okay, the next step is to find our vertical asymptote. And to do that, we take this denominator and set it equal to 0. So it's x. Let's go back down here. X squared minus 1 equals 0. Move the 1 to the other side, so x squared is equal to 1. Take the square root, so we get x equals plus or minus 1. And because they're asymptotes, they're equations. So we have x equals 1 and x equals -1. We have 2 equations here. 2 equations. Okay, and then I will explain this in a second. But to find the horizontal asymptote, it's horizontal because of the degree. We know it's not slant because to be a slant asymptote, the numerator degree has to be higher than the denominator. In this case, they're both a degree of 2. If you look here, let's get rid of this. You look here, they're both a degree of 2. They both have an exponent of 2, so they're the same. Okay, so we know it's horizontal. And that gives us the equation y equals 1 divided by 1, which is equal to 1. I'm about to explain why that comes up in a second. Okay, so those are the 4 things you need to find. Okay, so now that we're going to look here, here's the explanation of why we get our asymptotes. Okay, if this note n is less than m, we have a horizontal asymptote on the x-axis. Okay, so if the degree of the polynomial on the top is smaller than the degree of the polynomial on the bottom, then you have a horizontal asymptote on the x-axis. The one we did is when they are the same. And if they are the same, we take the 2 coefficients, a and b, here, and divide them. So if you go back to our example, our coefficients here were 1. Our coefficients again were 1 and 1. So 1 divided by 1 gave me this idea of what? Gave me this idea here of y equals 1. Okay, and the last one, if n is bigger, so if the denominator, if the numerator, we have an oblique asymptote, so if the numerator is bigger than the denominator, then we have to do division to get what that line is. And I'll show you how to do that in the next example. All right, so we're going to graph everything. Our first thing that we had to graph was our y-intercept, which is at the point 0, 6. So it's right there. Okay. We have our x-intercepts, which are at -3 here and +2. Okay, we're going to graph our horizontal lines, x equals. Okay, our x equals is here. X equals 1, and x equals -1. And then we had our horizontal asymptote at the equation y equals 1, which is there. Okay, so remember, asymptotes you approach but never touch. So how this works, you hug the line, go through the point, and hug the lines. So it just hugs each line. Okay, I knew to start down there because my point here, my point right there, is below. Okay, now this point up here is above. Okay, so since it's above, we're going to hug our line. And you always go away from asymptotes. So I'm going to hug the line. Why does it keep doing that? I'm going to hug the line. And because I know I'm going away from this horizontal asymptote down here, I want to go back up and curl it back up. And I'm having issues here with my laptop right now. Okay. And then same thing, you always start on the left, we hug the line, we go through our point and hug the other line. And then I know that I'm going to go down here because of that point right there. And that's it. That's your graph. It looks a little messy because these are just rough sketches. All right, let's try another one. Okay, again, to find my y-intercept, it's just these two numbers divided. So it's going to be y equals, I'm having many issues here with my laptop today. Y equals -12 divided by -1, which is 12. So we have a point at 0, 12. So let's graph that point. It's right there. Okay. Again, to find my x-intercepts, erase this. To find my x-intercepts, we take the numerator here and set it equal to 0. So it's x squared plus 4x minus 12. Okay, factor it. So -12 on top, 4 on the bottom, and the two numbers would be, looks like 6 and -2. So it would be x plus 6 and x minus 2 equals 0. So x will equal -6. X will equal 2. So we have a point at negative 6, 0. And we have a point at 2, 0. So we're going to graph both of those. Okay, so negative 6, 0. And 2, 0. Okay, back up to the top. The next step would be our vertical asymptotes. Or our vertical asymptote is just take our denominator and set equal to 0. So x minus 1 equals 0. So the equation would be x equals 1. Okay, so I'm going to draw that vertical line at x equals 1, which is in the middle here. I'm going to draw a dotted line, just like so. Okay. And the last step, figure out what type of asymptote we have. So right here, the degree of the top here is 2. The degree here is 1. So our numerator is bigger than our denominator, which means we have a slant asymptote, slant or oblique. Okay, so we have an oblique asymptote. So to do this, we have to do long division. So I'm going to rewrite our rational function down here. Okay, I'm going to do some synthetic. Okay, so it's 1, 4, negative 12. And then the opposite, which would be 1. Bring down the 1. Gives me 1 here. Which gives me 5, which gives me 5, which gives me negative 7. Now with these, because we're just finding an equation, we don't need the remainder, so the remainder goes away. Remember, start with the one on the left, that's 5, and add an x every time you go to the left. So it's y equals x plus 5. So that equation I need to now graph. Y equals x plus 5. So we started our y-intercept, which is 5. Use our slope to go up 1 over 1. And then up 1 over 1. And it should go through the negative 5. It's going to be slightly off depending on how your graphing is. Okay, so here we is. Okay, and again, always start on the left. So we start on the left. We know we're going to start above the line because of that point right there. So we're going to hug the line, go through the point, and because I have 2 points here, I'm going to hug that line as well. Okay, and then on the other side, I don't have any points here, so there's no graphs there. I have no points up here. So I'm going to go through this point, hugging the line, and it's going to look something like that. Okay, do another one. Okay, first step is always the y-intercept, so it's always number over number. Okay, so our y-intercept would be y equals 9 over negative 16. So we have a point at 0, negative 9 over 16, which is slightly less than 1, so do the best you can on this graph. Remember, these are rough sketches, so I'm going to have a point right there. Remember, to find our x-intercept, it's to take our numerator and to set it equal to 0, but we have a problem here. 9 cannot equal 0. Doesn't happen. So in this case, we don't have any x-intercepts because that does not happen. Okay. Vertical asymptote. To find our vertical asymptote, take your denominator, set it equal to 0. Okay. So x squared is equal to 16. So x equals plus or minus 4. So that means we have an equation of x equals 4 and x equals negative 4. Those are two vertical lines. I'm going to graph both of those. Okay, that's x equals 4. X equals negative 4. Okay, and the last one, the horizontal or vertical, again, go look at our degrees up at the top. And so we have a degree. Okay, the degree of the numerator here is, we don't have an x, so the degree of the numerator is 0. The degree over the denominator is 2. So n is smaller. If we go back to our chart, when n is smaller, we have a horizontal asymptote on the x-axis, which means our equation would be y equals 0. So let's graph that, y equals 0, which is just a dotted line along the x-axis. Okay, now we have three different places to graph. Okay. I know in the middle I'm going to start below because of that point right there. I always go away from the asymptotes and I hug the vertical ones. Okay. Because of that, that means that I'm going to have two more points here and here. Okay. So it's a rough sketch. So you start on the left, hug each line, and kind of shoot it up. So on the left, hug each line, and kind of shoot it to the side. And that would be your graph for that one. Okay, one more example. Right here. Okay. Start early. Okay, let's find the y-intercepts. Okay, so we're going to find the y-intercepts first. Remember, it's number over number, so in this case, it would be y equals negative 5 over 2. It doesn't divide, so we have a point at 0, negative 5 over 2, which would be 0 and negative 2.5. So 0, negative 2.5. It's somewhere about right there. Okay. Next thing we gotta do, find our x-intercepts. Our x-intercepts here. Okay, we take that. So this is the x-intercept. Take the numerator, set it equal to 0. So we have an x-intercept at 5. So we have a point at 5 comma 0. So let's graph that. Just right there. Okay. The next part would be the vertical asymptote. Vertical, I'm just going to put ASY asymptote. Okay, take your denominator, set equal to 0. So x equals negative 2. So let's graph that line, vertical line at negative 2. Like so. And the last one we're going to do is a horizontal. And I know it's horizontal because the degrees up here, it's 1 over 1. So that means they are the same. Okay, when they are the same, you take the coefficient. So the coefficient of the first one is 1, divided by the coefficient of the second one, which is 1. 1 divided by 1 is 1. So we have a horizontal at y equals 1. Okay, so we're going to start with the one with the points. We know we're going to start down here. We're going to hug the line. We're going to go up and through each point, and it's there. And what we know about this is it's kind of going to go, again, looking the same thing on the other side. So it's going to look something like that.